Hi, this segment on our discussion of enzymes talks about the classification of enzymes, and they can be classified into 6 categories based on what they do. So the first category that we'll talk about are the oxidoreductases, and these involve reactions that involve oxidation and reduction between the substrates. So they often involve the addition and removal of hydrogen and oxygen. One example is a reaction that can be seen in the lab with the use of the enzyme catalase. Catalase can naturally be found in our blood and also in animal tissues as well as yeast. So hydrogen peroxide, when it's produced in our bodies as a natural byproduct of metabolism, is toxic. So the enzyme catalase reduces it to water and oxygen. So another example is what happens in our bodies when we consume alcohol. So here is some ethyl alcohol down here, and it is a primary alcohol. And there is a substance in the body, the coenzyme NAD+, that plays a role in this, and it oxidizes. Remember that a primary alcohol will oxidize into an aldehyde. So there we have the ethanal, or the aldehyde with 2 carbons. So there's my oxidization symbol. So oxidation and reduction enzyme reactions are called oxidoreductases. Another one is called Transferases, and this involves the transfer of a group from one molecule to another. So in the metabolism of fructose in our body for energy, and in metabolism in general, it involves a substance called adenosine triphosphate, and that's called ATP. And one of the reactions that occurs again and again is the loss of a phosphate group to form adenosine diphosphate, and the addition of a phosphate group to form adenosine triphosphate. If you look in this molecule right here, you can see that there is a phosphate group right here, noticed by the phosphorus. And over here, we have 2. So we have transferred one of the phosphates from here to this molecule. So that is what is characterized by enzymes that are referred to as transferases. We're taking a portion, a group from one molecule, and transferring it to another. Another category is hydrolases, and we have talked about the act of hydrolysis, the use of water to break bonds, and hydrolases are enzymes that can speed this up. So one example is the digestion of carbohydrates. If we take in lactose, which is a disaccharide, so this is one sugar unit, and this is another sugar unit, and you can see they're connected. So lactose is a disaccharide, and lactase is the enzyme that works on it, and it breaks it down into 2 separate molecules, galactose and glucose. Now, if your body is limited in the amount of lactase it has, you may be one of the individuals that are lactose intolerant. Another example of hydrolases is a protease, which is an enzyme that breaks down proteins. So here we have a polypeptide bond. You can see that amide bond right here in a chain of amino acid residues to make proteins. And when the water is added, we will have the hydroxide getting added to one side and the hydrogen getting added to another, and either way we have our 2 amino acids here. And in this case, it shows to be 1 amino acid, and here we have a shortened peptide. So there's the implication that this is kind of continuing. So a protease isn't always going to break a polypeptide down into individual amino acids all the time, but it may break it down into smaller chunks. Um, Ligases is bonding together more than one thing. Here, this is something that can occur in metabolism as well. We have pyruvate combining with carbon dioxide to form this oxaloacetate. So when we are getting the bonding together of two substrates, this is called an action by an enzyme that would be in the ligases category. Isomerases change the way that a molecule is built, so it just rearranges the atom. One way that this can happen is glucose, the right-handed version of glucose in our body, or in foods or anything like that. Using glucose isomerase, we can change that into fructose. And this is something that commonly occurs in industry with the production of high fructose corn syrup. We can take starches, which are chains of glucose. So each glucose is a monomer in this polymer of starch, which is a chain of glucose, and a series of enzymatic reactions involve breaking these into individual glucose molecules and then ultimately converting the glucose into fructose. Another way that isomerases can work is taking a left-handed or a right-handed molecule and converting it to its chiral counterpart. So taking chiral molecules and converting one side into its mirror images. So the example down here is L-aniline, the left-handed version of alanine, being converted into the right-handed version. So simply just switching the molecules around so that you have the mirror image is an example of an enzyme that could be categorized as an isomerase. And the last category are called the Lyases, and they involve either the addition or removal of molecules at the site of a double bond. Here we can see at this double bond, we are adding water, and here you can see the OH and the H being added at the site of the double bond. And the opposite could be held true. We could be removing these molecules at the site of the double, at this site, which will ultimately produce a double bond. So water is often one of the substances involved with the Lyases category. So this summarizes my classification of enzymes, and I hope that you learned something. Thanks for watching.